Welcome to the lecture on calorific value. So in the earlier lectures we had discussed the determination of calorific value using bomb calorimeter, Junker's calorimeter and Boy's calorimeter. Using all these three calorimeters we are determining the calorific value. In addition to this we had determined we have calculated the calorific value using Dulong formula. In this video we will practice few problems on calorific value. So the first problem is calculate the gross and net calorific value of coal sample having the following composition: carbon 80%, hydrogen 7%, oxygen 3%, sulfur 3.5%, nitrogen 2% and ash 5%. So the given data: carbon 80%, hydrogen 7%, oxygen 3%, sulfur 3.5%, nitrogen 2% and ash 5%. So Dulong formula for GCV is 1 by 100 into 8080 percentage of carbon plus 34,500 hydrogen minus oxygen by 8 plus 2240 into percentage of sulfur calorie per gram. By substituting the given data, 1 by 100 into 8080 into percentage of carbon is given as 80%. So that's why into 80 plus 34,500 into percentage of hydrogen is 7 minus oxygen percent is 3 by 8 plus 2240 percentage of sulfur given is 3.5. By substituting this and simplifying, we will get 8828 calorie per gram. So this is the higher calorific value we have, or we can also call it as gross calorific value. Next, net calorific value. Net calorific value will be equal to GCV minus 0.09 into hydrogen into 587. So this will be equal to 8828 minus 0.09. Percentage of hydrogen is given as 7 into 7 into 587. So this will be equal to 8828 minus 369.81. So this will be equal to 8458.19 calorie per gram. So this is the net calorific value of the given coal sample. Next problem. Calculate the gross and net calorific value of fuel from the following data. Volume of fuel burnt at STP is 0.09 meter cube. Weight of water used for cooling is 25 kgs. Temperature of inlet and outlet water is 25 degrees centigrade. and 30 degrees centigrade respectively. Weight of water obtained by steam condensation is 0.02 kg. So let us note down the given data first. Volume of fuel burnt. Volume of fuel V is equal to 0.09 meter cube. Weight of water used for cooling. Weight of water is equal to, weight of water W is equal to 25 kgs. Temperature of inlet and outlet water. That means T1 is given as 25 degrees centigrade. Outlet water T2 is 30 degrees centigrade. Now, weight of water obtained by steam condensation. Weight of water by steam condensation. That is, M value is given as 0.02 kgs. From this, we can have to calculate the GCV and NCV. The formula for GCV for gaseous fuel is W into T2 minus T1 by V. So substituting the values, weight of water is 25, T2 minus T1 30 minus 25 by volume of water sample is 0.09 meter cube. So by substituting this, we will be getting 1388.9 calorie per gram. So this is the gross calorific value of the given fuel. Next we have to calculate the net calorific value. Net calorific value of a gaseous fuel can be determined using the formula NCV is equal to GCV minus M by V, that means weight of water through steam condensation, into 587. So this will be equal to 1388 minus M value here is 0.02 by volume of fuel taken is 0.09 meter cube into 587. Unit will be calorie per gram. So by substituting this, we will be getting 1388 minus, on simplification the value of this one will be 130.4. This will be equal to 1257.6 calorie per gram. This is the net calorific value of the given fuel. Next, the given problem is about 0.7 gram of fuel when burnt in bomb calorimeter, increase the temperature of water from 27 degrees centigrade to 29 degrees centigrade. If the calorimeter contains 250 gram of water and water equivalent is 150 gram, calculate the HCV of the fuel. So, first we will note down the given data. About 0.7 gram of the fuel is taken. That means amount of fuel burnt, X is equal to 0.7 grams. When burning in a boiling bomb calorimeter, the temperature of water is raised from 27 degrees centigrade to 29 degrees centigrade. That means initial temperature T1 is equal to 27 degrees centigrade. Final temperature T2 is equal to 29 degrees centigrade. Next, calorimeter contains 250 gram of water. That means weight of water is equal to 250 grams. Next, water equivalent is given. Weight of water is 250 grams means this is equal to capital W. So weight of water equivalent, let it be small w, 150 grams. So this is the data given to us. From this we have to calculate the HCV. So the formula for calculating the HCV is HCV is equal to weight of water plus weight of water equivalent into T2 minus T1 by amount of fuel taken, unit calorie per gram. So substituting the values, 250 plus water equivalent is 150 into T2 value is 29 degrees centigrade, T1 value is 27 degrees centigrade by 0.7. By simplifying this, we will be getting 1142.86 calorie per gram. So this is the higher calorific value of the given fuel. Next problem. About 0.8 gram of coal sample contains 90% carbon, 4% hydrogen, 6% ash. On testing with bomb calorimeter, the following data were recorded. So let us note down the data. So what is the data that is recorded? Weight of water. Weight of water capital W as 500 grams. Next, weight of water equivalent in calorimeter is 2200 grams. Rise in temperature is 2.4 degrees centigrade. Rise in temperature means T2 minus T1 is 2.4 degrees centigrade. Fuse wire correction. Fuse wire correction is 8 calorie. Acid correction is 50 calorie. And the coal sample taken, that means amount of coal sample, that is X is equal to 0.8 grams. So this is the data given to us. So we will substitute this data in the formula. So what is the formula for in the bomb calorimeter for calculating the GCV? GCV is equal to capital W plus small w, that means weight of water plus water equivalent into T2 minus T1 plus cooling correction minus fuse wire correction plus acid correction by X. X is the amount of the coal sample. So this will be equal to 500 plus 2200. T2 minus T1 is given as 2.4 degrees centigrade. As cooling correction is not even given, we won't consider it. Minus fuse wire correction is 8 plus acid correction is 50 by X value. X value is given as 0.8 grams. So simplifying this, we will be getting 10,034.4 calorie per gram. So this is the gross calorific value of the given coal sample. Now we have to calculate the net calorific value. Net calorific value will be equal to GCV minus 0.09% of hydrogen into latent heat of steam. That means 10,034.4 minus 0.09 percentage of hydrogen is given as 4 into latent heat of steam is 587. So by simplifying this, we will be getting 10,034.4 minus 211.32. This will be equal to 982.08 calorie per gram. This is the net calorific value of the given coal sample. Thank you. In the next video, we will discuss about the solid fuels.